In this lesson, I'm going to go over linear equations, direct and inverse variation questions, released questions, questions from the state that students have been missing. Okay, so first of all, we want to know what are the x and y intercepts of this function. Remember that this just is a y, so this is the same as saying y equals 3x plus 8. Okay, and 8 is our y-intercept. So right away, I know that I can cross off this choice, and I can cross off this choice because of the negatives. Okay, and then if you remember, your y-intercept all year, I've been asking you to write it as an ordered pair, 0, 8. So the only thing that's going to leave us is choice D. Now, if you're not sure about this, we can use our calculator. I'm going to be going back and forth between the different screens just so that you can have the calculator version. So if I'm going to put this into the calculator, I'm going to go to equations, and I'm going to do, oops, actually I'm not going to do that. I'm going to go to graph, and I'm just going to plug in 3x plus 8. Remember to use the x underneath the alpha key, plus 8, and I'm going to just draw it, and there it is. And if I want to find my x-intercept or my y, remember I'm going to hit G-solve. X-intercept is the same as root, so I'm going to hit root. It's going to tell me that it's negative 2.6 or negative 8/3. So that's just another way that you can determine what that is. All right, let's go to the next example. And I'm going to go back out to the presentation mode. Okay, it says graph the following function, then plot a point at the location of 0. So, of the 0. You can do this one of two ways. Remember, if you want to find your x and y intercepts, I'm going to cross out or put 0 in for y, so that I'm going to get negative 4x equals 8. Divide by negative 4. So my x-intercept is negative 2. So it's going to be right here. Okay, and there's going to be a graph feature for you on the SOL. If I want to find my y-intercept, I just put 0 in for x, and I get 2y equals 8. And if I divide by 2, the y-intercept is 4. So if I'm going to graph my line, it's right here. Okay, and the other thing you have to remember to do is to select this point here at the 0. Okay. Now I'm being asked to create a direct variation using two of the ordered pairs from those shown. So I have negative 5, 2. Right here. And if you remember, the direct variation always goes through 0, 0. So you want a point that's going to be on that line. So the easiest way to do that is we can look at the slope of this. The slope is negative 2/5. Okay, here to here. So if I go over 5 from here and up 2, this absolutely falls on the line. That's the point negative 10, 4. Or no, it's not, that's point negative 10. I've goofed this up. Bad, Miss Craig. We're going to go right below. All right, so then negative 10, negative 4 would be over down here, negative 4. So it looks like it's falling on the line. So I know I've got that point. Negative 2, negative 5 is going to be right here, and that doesn't really fall on that line. If I go 4, 10, that's going to be all the way up here. That's not going to fall on this straight line. If I do 2, 5, that's going to be here. It doesn't fall on this line, but 5, 2 is the other point that falls on that line. So remember that a direct variation always goes through that point 0, 0. All right. Select 3 points that would create a direct variation relationship. Remember that direct variations are y equals kx, and k, our constant of variation, is y divided by x. So all I'm going to do is take these points and divide them by x. So 3 divided by 4 is negative 3/4. 2 divided by negative 6 is negative 1/3. 16 divided by 4 is 4. 12 divided by 3 is 4. Negative 8 divided by negative 2 is 4. 9 divided by 2 is 3. 4 divided by 4 is 1. And 12 divided by negative 1 is 12. So these 3 points right here are going to be my direct variation. Okay. So now select 3 points that will create an inverse. Same ordered pairs, but remember the inverse variations are y equals k over x, and k is going to be xy. So let's check and see if any of these fit. So negative 4 times 3 is negative 12. Negative 6 times 2 is negative 12. 4 times 16 is 64. 3 times 12 is 36. Negative 2 times 8 is negative 16. 9 times 3 is 27. 4 times 4, actually, negative 2 times 8 is positive 16. Sorry, 4 times 4 is 16. And negative 1 times 12 is negative 12. So my 3 ordered pairs are going to be these two and this, because when I multiply my x and y's, it gives me negative 12. Okay, so that is the end of my linear examples. Have a great day.